गुड इवनिंग सर।
यस, गुड इवनिंग दिनेश। ये सेटअप कर लिया
गुड
आपने अपना
इवनिंग सर।
कोड?
यस सर।
ये लास्ट डे हमने कहाँ तक डिस्कस किया था केमिकल काइनेटिक्स में?
सर केमिकल काइनेटिक्स में हमने लास्ट टाइम डिस्कस करा था वो एंडोथर्मिक एंड एक्सोथर्मिक वाला जो ग्राफ्स थे ना,
जैसे
बस
एक्टिवेशन क्या में?
लास्ट टाइम पे वहां तक कोशिश हुआ था, वहां तक
एक्टिवेशन क्या एनर्जी?
एक्टिवेशन एनर्जी वगैरह,
यस यस यस,
एक्टिवेशन एनर्जी, थ्रेशोल्ड एनर्जी और ये सब डिस्कस करा था सर आपने।
एक्टिवेशन हो गया। यस टुडे, यस लेट मी स्टार्ट। द नेक्स्ट न्यू टॉपिक इज अर्नियस इक्वेशन इन केमिकल काइनेटिक्स। यस, व्हाइट बोर्ड पे आप सेटअप कीजिए।
यस सर। यस सर। The Arrhenius equation is K, which is rate constant, is equal to A e to the power minus EA by RT. A is the constant, E is the activation energy, R is the gas constant, T is the temperature. So this is the Arrhenius equation. It gives the relation between the rate constant and the activation energy.
Yes, good. How to determine activation energy, activation value from Arrhenius? Any derivation? Any graph slope?
How to determine what?
Yes,
Sir,
how
how
to
to determine
determine the value
activation?
of activation from Arrhenius equation?
Yes, sir. Sir, when you take natural log is equal to ln A, when you take natural log, ln K is equal to ln A minus EA by RT. When you plot it on a graph, ln K versus 1 by T, the slope would be equal to minus EA by R, and the intercept would be ln A. And from the slope, we can calculate the activation energy. When you take log, so the slope would be equal to minus EA by 2.303 into upon R. From the calculation of these slope, we can calculate the activation energy numerically.
Yes, good. What is integrated Arrhenius equation?
What is integrated? Arrhenius equation.
Yes.
Integrated Arrhenius equation, sir.
Yes.
I'm
What the
not able to
formula?
recall.
Yes. What the formula of integrated Arrhenius equation?
You are asking integrate. Sorry, sir, I'm not able to recall. If you are asking about log K2 by K1 is
Yes,
equal to EA
yes,
by
yes,
2.603 R,
yes. Yes, log
bracket में 1 by T1
ये upon
minus
2.3
1
and
by 2.
1.2. Yes, integrated Arrhenius equation. Yes.
Okay, okay.
So what is the difference between
Okay.
Arrhenius
Okay.
equation and integrated Arrhenius equation? What the difference?
Sir, what is the difference, sir? Basically, if you study, sir, because sir, we are deriving for example, for studying the studying the same reaction at two different temperature with two different rate constant. If you want to study, so we derive this integrated Arrhenius equation only from the above, from the previous equation. So this is the basic difference. For example, when we take K1 is equal to A, e की power minus ART 1, and when we take K2 is equal to A, e की power minus 1 upon RT 2 on taking log on both the sides, and taking log and dividing equation 1 by 2, we derive the integrated equation, sir, from that. So it is basically studying the reaction at two different temperature and with two different rate constant, and given the fact that the activation energy is similar, is same for both the reaction, because it is the same reaction.
Yes, good. Then next move on catalysis. What is catalysis? What the relation between catalysis and activation energy and Arrhenius equation? Explain.
Yes, sir. So basically, the catalysis uh, is a chemical entity which speed up the reaction without taking participation in the reaction. So basic definition of catalysis is this. And for example, for a chemical reaction, for example, rate constant is equal to A is equal to E to the power minus EA by RT. For example, when you take the catalysis, so Kc is equal to A e की power minus E to the power EAC upon में RT. So when you divide the equation second by first, so log Kc upon में K, A would be cancelled out, E to EAC upon में RT plus E upon में RT. On solving log Kc is equal to Kc upon में K is equal to E to the power 1 by RT minus EAC plus A. When you plot the activation energy, potential energy versus reaction coordinate, this activation energy decreases. Like earlier it was EA, it provides an alternative path for the reaction. So the decrease, the new activation energy would become EAC, which is shown by the dash. So this is the basic graph I've shown, sir.
Yes, good. Yes, good. Next move on, next topic is steady state approximation. What the main application of steady state approximation in chemical kinetics? Explain.
Sir, steady state approximation.
Yes.
Sir, for example, if any entity is present in the is unstable and is present for the short span of time, sir. So we take the rate of that entity is equal to 0. For example, the differentiation of that entity is taken. For example, any radical. For example, radical is r dash. So we take that dr by dt is equal to 0 and we derive the rate following with the use of it. In experimental basis, we usually do steady state with the help of using ice also. When we put the reactants in ice also. So these we study about steady state approximation.
Yes. What the difference between steady state
It is
approximation and equilibrium approximation?
in equilibrium approximation.
Yes.
Sorry, sir, I'm not able to tell this difference.
Any limitation of steady state approximation? Any drawback?
I would say that steady state approximation is only unstable like radicals and carbocation, etc. But it is not applicable to each and every chemical reactions that we use. And for deriving it experimentally, it is very hard for the reaction to to put it at a steady state, because there can be any human error, might be very impure ice also we are putting in it, so it may hamper the reaction process that is happening. So what I feel is these are the limitations.
Yes, good. Next, move on Lindemann theory. What the main application of Lindemann theory in chemical kinetics? Explain.
Sir, is it Lindemann theory is this Michael-Mental equation, sir? Is it the same equation, Michael-Mental equation?
Michael-Mention equation is different. Michael-Mention equation is enzyme catalyst.
Yes,
Lindemann
sir, enzyme catalyst.
yes. Yeah, do you have any idea?
Sorry, sir. Sir, I'm not able to recall, sir. I have heard this word, but I'm not
Okay, no problem. Yes.
able to
You have
exactly.
any, you have to study. Next, move on Michael-Mention equation. Yes. What the main application of Michael-Mention equation? Explain.
Sir, Michael-Mental equation is um, Michael-Mental equation is when we use enzyme as a catalysis in the chemical reaction. So we study how the effect of enzyme on the reaction rate. So we study basically the the reaction rate of the enzyme, how it is reacting with our substrate, and how fast it has um, how fast the products are getting formed. So this is the basic funda behind it, sir.
What the derivation? Do you have any idea of derivation of enzyme catalyst?
Yes, sir, I have some ideas, sir. Yes, sir.
Yes.
Sir, I have, sir, I'm not able to exactly recall it, but I remember the rate is equal to K2 into S divided by Km plus S. So Km is the Michael constant, sir.
Yes,
At the
PM is
initial
Michael
phase,
constant.
rate is directly proportional to the rate constant, but when you take at higher concentration of the substrate, it becomes dependent on the substrate. So the reaction which goes like this only. This I remember.
Yes.
It is maximum at a substrate 2 by 2. S
Yes.
by 2 it is maximum.
Yes. If you
This I
Km, yes, yes, right.
yes sir.
If Km greater than substrate, so what will be the product and order of reaction?
Km is hmm,
Km greater than substrate, Km less than substrate, and Km
it
equal.
will be first order. It will be first order. It would be first order. It would be first order, sir.
Yes. On
It
Km
would be
less
first
than
order.
substrate,
Km if less than substrate, it would be zero order, sir.
why? What the reason?
Sir, because if it is substrate is more, then Km would be easily be nullified and substrate will cancel out. So rate is equal to K2 only, which is depend on the rate constant only. It usually happen as zero order reaction when the rate of the reaction doesn't depend on the concentration.
Yes, good. And what is line wear work method? In line wear work method.
So what the
Line
Langmuir adsorption we're talking about.
line wear work method in Michelmanson equation.
Sorry, sir, I'm not able to recall. Langmuir, it is Langmuir. What's
Line wear, Line.
Langmuir?
Yes,
Huh. Sorry, sir,
WEA.
I've not read, sir. This. I'm
Okay,
not
no
read.
problem. Yes, any drawback and limitation of Michelmanson catalyst equation?
Limitations, sir. Sir, I would say the limitation would be the enzymes after making the products. It is very hard to to extract out the enzymes, all the enzymes from the reaction. That may be a limitation. Mm, uh, and different in experimentally basis we see it is very hard to judge the rate of the reaction because at different substrate it is showing different orders, so it is hard to justify it.
Yes.
So I'm just guessing the limitation.
Yes, okay, good point. Next, move on collision theory. What the main application of collision
Yes,
theory in chemical kinetics?
yes sir. Yes, you told me in earlier class you have to read about collision theory and transition state theory earlier.
Yes, collision, transition state theory.
Yes sir. Sir, main application you're talking about, right? Sir, the collision theory is basically when we study biomolecular collisions of gaseous molecules, then we consider it collision theory. Or basically, it tells that all the collision does not lead to products, but when the collision has certain minimum energy, generally it only leads to the formation of products, and there should be a minimum geometry for the collisions so that to in order to form the products. And when we derive the collision theory, it generally forms uh, pre-exponential factor, that is a is directly proportional to t half. and a square root of T, where T is temperature and A is pre-exponential factor. We derive it in the collision theory, sir.
Yes, good. Any derivation of collision theory? You know, who was developed collision theory?
Yes, sir. Who has developed collision? Sir, I remember, sir, transition state theory is developed by Ehring, but collision, I've read it about the after this interview, but name is not written.
Yes, yes. Collision theory is developed
Collision theory must be
Arrhenius and Wantoff, scientist.
Wantoff.
Yes. What's the relation between collision theory and Arrhenius and Wantoff equation? Any relation?
Between collision and Arrhenius.
Yes, and Wantoff.
Sorry, sir, I'm not able to exactly recall it, but
Okay, no problem. Yes, you look them. You have to study about this. Yes. Two terms used in collision theory: steric factor and orientation factor. What are the uses
yes,
of
sir.
this factor in collision theory? Can you explain?
Sir, orientation. Sir, is it the E is equal to E naught minus RT? Is it the relation you're talking about?
Yes.
The earlier one, the relation.
Yes. Yes. Yes.
This is the relation.
Activation and need.
Yes. Sir, the orientation is generally, sir, not all the molecules that are colliding will form products, but when two molecules, when they collide, for example, they collide in a certain orientation, when they form a product, so that particular orientation is called the orientation one. Steric factor, sir, orientation.
A proportional to root P. Yes, no.
Yes, sir.
A
A is proportional to root T.
Yes. A is
root T, sir.
Arrhenius free exponential factor. Yes, no.
Yes, sir. And sir, steric, sir, I'm not able to recall, sir. Steric, I'm not able to.
No problem. You look there in the derivation. Yes, no.
Okay, sir.
Next, any limitation of collision theory? Limitation of collision theory.
Yes, sir. There are many limitations of collision theory, sir. Because, for example, we collision theory is generally based on a gaseous medium, but mostly the reactions are taking place in a solution phase. And sir, collision theory it defines the minimum geometry that should be formed so as to form the products, but it does not clearly tells you what is the minimum geometry. Third is, sir, it does not tell you the effect of pressure on the rate of the reaction, uh, and sir, it does not tell you the effect of dielectric constant on the rate of reaction, and
Yes, is not
and
applicable in the case of reversible reactions. Yes, no.
yes, sir.
The next move on, next theory is activated complex
Uh,
theory or transition state theory. What the main application of activation complex theory and transition state theory in chemical kinetics? Explain.
Sir, what you ask? Can you repeat, sir? Activated. What is transition state theory?
Yes, activated
Main
complex theory.
application.
Yes, main application. Who was developed?
Sir, it was developed by Eyring, scientist Eyring.
Yes.
Sir, it is generally defined that whatever the reaction that is taking place, it generally forms an activated complex, and that converts into the product. है ना? This is the basically, and this theory is applicable in all mediums, whatever maybe in both gas and liquid. And generally, when the transition state is formed, it generally converts into the product. For example, sir, in activated complex, the activity complex can go towards any of the reactants and products. But if you consider the transition state, when the reactants convert into the transition state, it will only go to the products. So this is the difference. It is the basic difference between the two. And sir, the for example, activated complex, here it is A is directly proportional to T. That is, A is directly proportional to T. And sir, the major application of this theory is, sir, it clearly defines. First is, it is applicable in all the mediums and in most of the reactions that is taking place in our experimental basis. The second is, sir, this theory explains the effect of pressure and on the rate of the reaction. Sir, defines this theory defines the and this theory clearly, the result are mostly experimental, are the rate of the reaction, that is K, which is the value is nearly equal to the experimental value that is we perform in lab. So these are the basic applications, sir.
Yes, good. Yes, some terms used in transition state theory. Standard free
Yes, sir.
energy, standard entropy of activation, standard enthalpy. Yes, what are the uses of these term in activated complex theory? Any formula?
standard enthalpy, standard entropy, and standard Gibbs free energy, sir.
Yes. Yes.
Sir, on the basis of derivation, uh, on the basis Gibbs free energy is equal to delta H minus T delta S. This is the this is the this is the this is the equation that you are asking about, and we take delta H is equal to U delta U plus delta Ng RT minus T delta S, and when we divide it divide by minus E RT, when we take this is the basic.
Yes, good, good. Yeah, next move
Do you
on.
want me the
Yes.
Hmm.
Yeah, next
Do
move
you want me
on.
to solve the whole equation?
Yes, K is equal to KBT upon H into E की power del S minus T del S upon RT. This is the formula of alpha.
Okay. You want the whole derivation? है ना?
Yes, good. Any limitation of activity transition theory?
Limitation.
Drawback.
I have only studied the. I have only studied the application part of that.
Okay, okay.
In my notes, there was no limitations written.
Next, move on salt effect. What is salt effect?
Salt effect.
Yes.
Sorry, sir. I haven't read this salt effect, sir.
The next move on. What the difference between slow and fast reaction and chain reaction?
Slow and fast and chain reaction. So the slow reaction are those generally when the time generally is more than 1 minute, and fast reaction are those reaction which generally take within with time is less than 1 minute, and the chain reaction are those, sir, which generally propagates for example free radicals are formed, so it kept on moving. So for example nuclear fission is there, so radicals keep on forming. So this is the example of chain reactions.
Yes, good. And next is what the difference between parallel reaction and consecutive reaction?
Sir, the basic difference is in a consecutive reaction, for example, A goes to B, B goes to C. So B is just an intermediate between the two. So its reaction slightly goes up and slightly goes down of the with the reaction. And in the parallel reaction, for example, the reactant A is there. So simultaneously, both B and C will be formed in the parallel reaction.
Yes, good. Any derivation of parallel and conjugative reaction?
Yes, sir. So for example, parallel reaction is there, A goes to B and A goes to C. For example, if we take rate constant to be K1 and K2, if we take, for example, it is following the first order reaction with respect to first one and with respect to both the reactions, if it is forming. So minus dA by dt is equal to plus Ka plus K2A. When we take K1 plus K2 common, A is there, and on the basis of integration A0 goes to A and 0 to T, it will form is equal to A is equal to A0 e to the power minus K1 plus K2 bracket, and after the bracket is there. This is the derivation of parallel reaction.
Yes, good. Any limitation of each one? Slow reaction, chain reaction, parallel reaction, and conjugative reaction. This concept is completed. Yes.
Limitations in parallel reaction, if there you talk about reaction, the same reactant is getting depleted. For example, if the first one is first order reaction and if the second one is second order or higher order reaction, so in experimental basis it is very hard to study the parallel reaction if it is simultaneously one is low of lower oxidation lower order and the other one is of higher order. And in consecutive reaction it is very hard to you know